The Abrams can also fire with great accuracy at speed. That capability depends on a platform that remains stable at all times. The same specification required by the ancient Egyptians for their chariots. The technology needed for the weapon's stability was perfected late in the 20th century. Gun stabilizers use gyroscopes to keep the weapon locked on target, regardless of the tank's movement over the ground.
Any type of terrain you can fire on. Doesn't matter how the tank is sitting. The hull can be sitting a certain way, the bottom part of the tank can be sitting a certain way, but the gun is still gonna be leveled out, ready to shoot.
The Abrams uses superior range to outgun opposing tanks. It's a deadly tactic. In World War II, it was also Germany's belated but effective response to the Soviet T-34. The Germans countered the T-34 with the Tiger, a heavy tank with a long, highly accurate gun. The Tiger had a bloody impact on the battlefield. British tank officer Peter Gudgeon witnessed its power firsthand. This is the actual Tiger that almost killed him in the Battle for Tunis in 1943. He and his men engaged a group of German tanks dug in at the top of a hill.
First we knew about it was when the leading tank on my right blew up in a massive explosion. The commander and his wireless operator were blown out of the top of the turret. The tank was ablaze, an inferno. The next thing I felt was a shot passing right down my tank, just missing my right leg. I felt the draft of it on my right leg. And it crashed through into the engine and set us on fire.
Gudgeon expected more shots, but he and his men got lucky. A shot from another British tank struck the Tiger in the turret, disabling it. The German crew bailed out and fled.
Hit it anywhere else than where it did, probably wouldn't have made any difference. One amazingly lucky hit.
It wasn't long before the sophisticated firepower of the Tiger came up against the powerful T-34. They met in one of the biggest tank battles of all time. The outcome was a referendum on military capacity and on technological philosophy. 1943, Kursk, Western Russia. Nearby, in the village of Prokhorovka, one of history's most ferocious tank confrontations began. 450 German and 800 Russian tanks amassed near the top of a hill.
You are face to face in this incredible encounter. It's almost like hand-to-hand combat with tanks.
Ahead would have been hundreds of German tanks. And every single crewman must have felt they were lining up on him personally.
You don't have time to think. You fire, you shoot, you ram.
The feeling of vulnerability is completely accentuated by this lack of vision. All I can see is the next slope ahead and very little else. They must have felt dreadfully vulnerable.
The losses are phenomenal. You have to imagine men bailing out of tanks that are on fire, and when you bail out, you're going to get shot.
The casualties on both sides were terrible.
It's the Holocaust on the tank battlefield, because the next day there are these hundreds of burning hulks.
Though the numbers are disputed, it's estimated that close to 500 tanks were destroyed that day. And that was just one engagement in the larger battle for Kursk, which ultimately involved more than 6,000 tanks. After 7 weeks of fierce fighting, the Soviets were finally able to stop the German offensive. The Soviets suffered far greater personnel and equipment losses than the Germans, but in the long run, they were better able to absorb them, in part because of their low-tech approach to tank engineering.
But if there's one thing that characterizes all these Russian tanks, it's the crude finish, and it's very noticeable here on the T-34's turret. You can see cast markings, weld markings. Now, if you compare the rough finish of this tank with the German Panther over there, the contrast is fantastic. It's as if those tanks were finished off in the Mercedes-Benz body shop. It's a beautifully made machine.
Though lighter and cheaper than the Tiger, the Panther was a typical example of complex German engineering. But such precision came at the expense of manufacturing capacity. Fewer than 1,400 Tigers and only 6,000 Panthers were ever finished. The Russians, on the other hand, could crank out T-34s. Mikhail Kushkin's simple, reliable design allowed them to mass-produce more than 57,000 and overcome the Germans with sheer force of numbers. As the war progressed and Germany was forced from offense to defense, the Army reassessed its need for fast tanks to conquer enemy territory. Now trying to defend the fatherland, they sacrificed speed for better protection. The result was the Tiger II, or King Tiger. With double the frontal armor of its predecessor, this was the heaviest tank used in World War II. It didn't prevent the German defeat, but it was another example of the mission-specific trade-offs between speed, armor, and firepower. With the changing requirements, shifting fronts, and huge armies, World War II drove rapid advances in tank design. And it saw commanders developing new tactics to take advantage of these powerful, mobile weapons. Guns got bigger, armor got thicker, and killing capacity grew. By the close of the war, J. Walter Christie's vision of an armored racing vehicle had evolved into an all-round fighting machine that commanded the battlefield. A machine that would be effective for decades, until tanks built for big set-piece battles found themselves up against a new, deadly, and far more flexible weapon. A weapon that prompted some to wonder whether the big battle tank, like the Chariot long before it, would become obsolete. In 1973, a surprise attack on Israel by Egypt and Syria ignited the Yom Kippur War. Israel's tank forces, which had previously seemed invincible, suffered devastating losses. For 40 years, the most potent anti-tank weapon on the battlefield had been another tank. But in this war, Egyptian soldiers had another effective option.
There was an introduction of something that changed the equation on the battlefield, and that was this light, portable anti-tank weapon.
The Israeli tanks were being attacked by missiles that could be carried in suitcases and by rocket-propelled grenades. Anti-tank explosives had been around since World War II, but the missiles were a major improvement. A portable guided delivery system with a deadly warhead. Known as shaped charges, the warheads were designed to cut through even the thickest tank armor.
This is a shaped charge. The top part here is filled with explosive. This is designed so that when the explosion travels down here, this copper actually turns to liquid and is concentrated on a point down here. And that allows the liquid metal to actually puncture straight through the target.
It will completely carve up the crew or it will set off ammunition fires, which in turn, of course, will produce internal explosions, which will completely finish them.
But of course, as soon as engineers realized what they were up against, they began searching for the next protective counterpunch to defend against it. (1969). German armor scientist Manfred Held made a surprising discovery while conducting research in the Middle East. Held was testing shaped charge warheads on the wrecks of battle-damaged tanks.
I was alone there. I was a project leader. I made my own pictures from every test.
Held detonated his shaped charges on the tank's turrets, fully expecting them to perforate the armor and destroy the tanks. But when he reviewed his footage, he noticed much bigger explosions than he had anticipated. Upon investigation, he discovered that the shaped charges had set off live ammunition still sitting in the turret. He realized that the secondary explosion had neutralized the effect of the shaped charges.
So the stronger reaction have reduced the penetration capability.
By accident, Held had discovered a new way to protect a tank: explosive reactive armor. Like many modern tanks, the Israeli Blazer features the new protection. Its most vulnerable points, the front arc and turret, are fitted with close to 40 reactive plates. If a plate is hit, it explodes, countering the shaped charge and leaving the tank unharmed. A demonstration reveals how it works. Two towers of steel stand in for the armor of a tank. Each will take the brunt of a shaped charge attack. A charge is placed on top of each tower. There will be two explosions, one with explosive reactive protection and one without. The one with gets a sheet of plastic explosive placed at an angle between the shaped charge and the top steel block. This simulates the position of the plate on a tank.
When the shaped charge is fired, it will detonate the sheet of plastic explosive and hopefully disrupt the blast. Then we can compare the number of steel plates penetrated with the protection of explosive reactive armor and without. Firing in 3, 2, 1, firing! Firing! There was a huge release of energy in both those two explosions. This first stack, we didn't have anything between the shaped charge and the top plate.
The shaped charge left a neat entry hole, and the blast penetrated almost 6 plates. That's 6 inches of steel.
It's actually gone almost all the way through it. If we compare that to the stack that was protected by our simulated explosive reactive armor, the entry on the top plate is a lot messier. A lot of this seems to have been disrupted.
But the shaped charge has only gone through 3.5 plates. The explosive reactive armor has reduced the impact by almost half.
So had this been an attack on a tank, I think the protection offered by the explosive reactive armor could well have saved the crew's lives.
Once again, armor had caught up with the innovative weapons intent on destroying it. Israel was the first to adopt the explosive reactive armor. It is just one of many safety features designed into Israel's main battle tank, the Merkava. After losing 2,500 men, most of them tank soldiers in the Yom Kippur War, the Israelis placed a high premium on tank crew protection. For such a small country with so few soldiers, the loss of highly skilled tank crews is a political, economic, and military tragedy. Soldiers are extremely precious, so their safety is the #1 priority. Firepower and mobility come second and third. Unlike all other main battle tanks, the Merkava's engine is in front, which puts an extra barrier between the crew and incoming fire. The tank's shape, streamlined and flat, makes it difficult to hit. Even the turret is designed to present a low-profile target.
The turret is basically on the top. It's very narrow, so it will be very, very hard to hit. As you can see, it's shaped as an arrow to the front.
If the tank is hit, soldiers have an increased chance of survival because ammunition and flammable liquids are kept separate from the crew area. And the crew can make a rapid exit through a rear-facing escape hatch.
What happens, I give my crew just a command. They all get out of their cells and just come out of the tank from this rear hatch. We can open it from inside. It just opens on the top and on the bottom. The whole crew gets out and we go to a safer spot.
The Israeli Merkava represents the pinnacle of crew safety, a conscious decision by the Israeli army to put protection first. But it is not necessarily the best all-round tank. Other countries, like the US, opt for a different balance of firepower, speed, and protection. The American Abrams has that balance. Early versions of the tank played a critical role in ground war offensives during both Gulf Wars. The latest Abrams, the M1A2, is even more intimidating, with improved armaments, protection, and electronics. Its massive 120mm gun has a laser rangefinder, and it's tough, protected by multiple layers of steel and ceramics and an option of reactive armor.
Abrams tank is the most powerful battle tank in the world right now. There is no tank that can match an Abrams in open battle.
At close to 70 tons, the Abrams is one of the largest tanks ever to do battle. Inevitably, such size comes with consequences. It guzzles fuel at nearly 2 gallons per mile and is heavy to transport. But on open battlefields, its ability to project power far outweighs these kinds of logistical problems.
If you're projecting the possibility of a war with, say, an enemy like North Korea, that will be a conventional war. And you'll need an Abrams. You've got to have an Abrams.
But the Abrams isn't ideal for all conflicts, particularly the asymmetric battles of today, which are often fought in urban environments and against highly mobile insurgents.
Definitely the place that is the most dangerous for using a tank would be an urban environment. The most restrictions, the most opportunity to get behind you or over you to attack you.
Because of these limitations, weapons designers have had to produce less powerful but more flexible machines. The Stryker, used in Iraq since 2003, is an armored personnel carrier with 8 wheels instead of tracks. It's used as a battlefield taxi, delivering troops with speed and some protection. The Stryker's firepower and armor are inferior to that of the Abrams, and in Iraq it proved vulnerable to roadside bombs. But it is 3 times lighter than a battle tank, so it can easily be airlifted to trouble spots. And in urban environments, it is far more mobile.
A Stryker can go down streets that an Abrams tank is too large to get through. because the tank is so big and so powerful.
The Stryker is the latest in a tradition of lighter vehicles that have evolved alongside tanks in response to battlefield demands. Most recognizable is the Jeep, America's transport backbone during World War II. More recently, the Humvee has entered the battlefield as a hybrid troop carrier, ambulance, and automatic weapons platform. Equipped with a roof-mounted .50 caliber machine gun, it has found an important role in modern combat. Strykers and Humvees use their superior mobility to evade enemy guns. But because those guns are always becoming more potent, the most effective way to avoid being hit is to avoid being detected in the first place.
New rule of warfare is, if you can see it, you can hit it. If you can hit it, you can kill it. Doesn't matter what it is. So that makes the importance of not being seen much greater than it ever has been in the past.
And so designers of future weapons are investigating a new dimension of tank design: invisibility. Cutting-edge technologies from camouflage to stealth are being researched and tested. These Leopard 2 tanks from the Armored Battalion of the Danish Army are on their way to Helmand Province in Afghanistan. But before they leave, they are given a new skin to hide their presence from the enemy. Anti-tank weapons use thermal targeting to zero in on a tank's telltale heat signature. This camouflage helps disguise it. The skin combines layers of high-tech materials that deflect enemy radar and reduce the tank's thermal footprint. It's far from perfect, but the difference is easy to see. The front tank, without the new camouflage, shows up white-hot on the thermal imager. The second tank, which does have the new skin, is more difficult to see.
Most of the tank will not be visible on a thermal imager, so you will be able to get up and get the first shot before they even recognize you.
Though still in its infancy, some variation of camouflage technology may be the next step forward that gives its user an advantage on the battlefield. A battlefield that is always changing, where tanks must adapt to survive. Since before the Pharaohs, the wheels of war have turned beneath the most destructive fighting machines the world has ever seen. And thanks to technology's dynamic advance, the mobile forces of the world's armies have evolved to strike out at high speed and with great force. Over thousands of years, these machines have helped drive the changing tactics of battle, both protecting and killing with ever greater efficiency. The future will be no different, shaped by the awesome combination of speed, armor, and firepower. Next time on Ground War, artillery projects power from afar.
Fire! Artillery in the ancient world had a shock and awe value.
Battlefield engineers push the boundaries of distance.
We get these stories of them launching things over the walls, the heads of their enemies.
Firepower.
Only the artillery can flatten enemy barbed wire. Only artillery can destroy the trenches.
And accuracy.
We're a precise organization. We deal in precision.
Firepower on Ground War. For streaming programs and more information about the history of ground warfare and the technological advances that have driven the evolution of battle, visit pbs.org.